Hi everyone, this is just a quick video in which we're going to go through a question that requires us to calculate the amount of kinetic energy stored within a moving object. A bowling ball with a mass of 5.00 kilograms is traveling down a lane towards bowling pins at a speed of 7.50 meters per second. How much kinetic energy is within the bowling ball as it moves towards the pins? Ignore the effects of friction and assume a constant speed. That final point about ignoring the effects of friction and assuming a constant speed for the movement of the bowling ball as it is moving towards the bowling pins refers to the fact that in reality, as the ball is moving along the surface of the lane, there is a conversion of kinetic energy into thermal energy, heat, and as a consequence, the bowling ball will actually slow down. However, for this question, we're going to essentially assume that those effects are negligible and that the speed of the bowling ball is maintained at 7.50 meters per second until it reaches the end of the lane and makes an impact with the bowling pins. Okay, so the equation we need to calculate the amount of kinetic energy within the bowling ball as it's moving towards the bowling pins, the equation we need is as follows. EK, which means kinetic energy, is equal to half of the mass times v squared. Now, conventionally, v means velocity, which is a vector. It has a magnitude and a direction. However, in this example, it means speed, which is a scalar. It only has magnitude. And we only square the value of speed. We do not square the value for the mass of the moving object. We only square the value for the speed at which it is moving. Okay, so to calculate the amount of kinetic energy within the moving bowling ball, we take a decimal value of 0.5, which represents 1/2. We multiply that by the mass of the bowling ball, which is 5.00 kilograms. Multiply that by the speed at which it is traveling, 7.50 meters per second, but we square that value for the speed, so it'll be 7.50 squared. And we put that into a calculator, we get an answer of 140.625 joules, because joules is the unit we need to represent kinetic energy. Because we're given values within the question to 3 significant figures, it is best to round our answer to 3 significant figures. So the fourth significant figure within this answer is 6, so we round upwards. So our answer with the units of joules to represent the amount of kinetic energy within the bowling ball is 141 joules. Now, if we want to express our answer in kilojoules, we take our answer in joules, 141 joules, and we divide by 1000. And we get an answer to 3 significant figures of 0.141 kilojoules. So the amount of kinetic energy within this bowling ball as it's traveling towards the bowling pins in joules is 141 joules, and in kilojoules it's 0.141 kilojoules. Thank you for watching.